we are continuing the section of 3-4 in linear programming. So right here we're going 3-4 linear programming. Now I've set this up right here. We're going to graph the blue line, we're going to graph the red line, and we're going to graph the green line. All right, two of these are functions. One of these is not a function. All right, so the blue line. Why is the blue line the easiest? Because we have two things. What? That's right, the slope and the y-intercept. Good job, you all. Participate. All right. What's the slope, Nick? 3. We'll put 3 over 1. Goes up 3 units over 1 unit. What's the y-intercept? Dylan? Correct. Correct. Right there. Right there at a 6. Let's plot that. Ready? 1, 2, 3, 4, 5, 6. And we're going to go up 3 units and over. Uh-oh, I don't have enough room. So what can I do? Go down 3 units and over 1 unit. Down 3 units and over 1 unit. Now, how do you check it? You can check it by doing the reverse that we tried to do. Up 3 over 1. Up 3 over 1. Up 3 over 1. And is it a solid or dotted? Definitely solid because it's less than or equal to. And you create a nice solid line going through all of those points. And if it's less than or equal to, we will eventually shade everything over here underneath the line, right in this area. You can shade gently if you like to. I'm going to shade at the very, very end. Okay. Red line's more difficult. What form is this technically in? We don't call it, oh, that's not the A, that's the B. All right. If we wanted to write standard form, it would be 3x plus 4y is less than or equal to 3. Now we have it in what? We have it in standard form. Okay? But we're going to solve. Right now we're going to solve for the y value. So we're going to solve for it. So what's the first step that I would have to do? Get rid of the x. And we have, right here, this zeroes out. These are additive inverses. We have 4y is less than or equal to negative 3x plus 3. Notice I just brought the negative 3x down. The only reason I put a couple of lines here is to make sure everybody's aware whenever you move a number across the inequality sign, it becomes the opposite of what it is. All right? You don't have to do this. I just do it when I'm teaching you all. So, what's the final step? Very good. Divide everything by 4. And it's not a really pretty equation. It's y is less than or equal to negative 3/4 x plus 3/4. Now, you can use the graphing calculator, type that equation in, and check your table. But I'm not going to do that. Right now, I'm just going to make a quick little table for myself. And the easiest number that I can plug in that I will know get a good result, if I plug in a 1 right there, if I plug in a 1, I get a negative 3/4 and a positive 3/4 adding together. So I know if I plug in a 1, I'm going to get a 0. Now, if you didn't recognize that, use the graphing calculator. Okay? So what do I do with this 1, 0? I go right over here, and I plot 1, 0. Now, what's my slope of this? My slope, that's right, negative 3/4. My y-intercept is a positive 3/4, but I don't really care about my y-intercept right now. I actually care about applying this slope. So this slope tells me two things. It tells me I got to go down 3 units and over 4 units to the right. So right here, I'm going to go down 1, 2, 3, and over 1, 2, 3, 4, and put a point. You see that down 3 and over 4 ratio. I ran out of room, so now I'm going to go up 3 and over 1, 2, 3, 4, and put this point right there. And now I have enough information. Wait, I think I went too far. Up 1, 2, 3, over 1, 2, 3, 4. Yeah, went over a little too far there. There we go. All right. That's still down 3 over 4. Make a nice, solid line through all of those points. Not there. There we go. Let's look at this. It says y is less than or equal to. So right now, technically everything below this line will be shaded. So this will be shaded right and here. And last but not least, it says we have to do x is greater than or equal to a -2. Now this is going to be a vertical line, everybody. This is vertical. It has an x-intercept, but it does not have a y-intercept. The x-intercept is at -2, 0, right here. That's the x-intercept. It has an undefined slope. So this one right here, if I said, what's the slope? The correct answer would be, it's undefined, because it's a vertical line. And you graph that vertical line going straight down where x is equal to a -2. And where would I shade that? I would shade everything going to the right. So let me explain something right now. I'm going to do a better job shading here. I'm going to shade everything inside. You guys see where the boundary was created? All right. This is my feasible region. All right. And I'm going to do a couple of points that we have to pay attention to. One of the points is right here. That's one of the points we have to worry about. The other point is right here. All right. So we have two vertices, everybody. We have two vertices. So right now, I'm going to list my vertices right here. One of them is easy to find. One of them is slightly more difficult. So let's think about this. What's this ordered pair? Where do they cross? They cross at a -2, 0. The green line and the blue line touch at -2, 0. What do we have? Where do we have to find the point of intersection? What two lines do we have to set equal to each other? The red and the blue. See how the red line and the blue line, they cross right here? So right now, let's look at our equations for the red and the blue. We have y is basically, I know it's less than or equal to, but I'm going to put y equals because we're trying to find a point. Y equals 3x plus 6. And then here we have y equals -3/4 x plus 3/4. And we're going to find the point of intersection, and we're going to put our answer right in here. If you set them equal to each other, you say 3x plus 6 equals -3/4 x plus 3/4, and we are going to solve for x. Okay? Now, to make this a little bit easier, everybody, when you see a whole bunch of fourths that you have to work with, just to make it easier, if you wanted to, you don't have to do this, you could multiply everything by 4 just to make things a little bit easier and get rid of those fourths in the denominator. So I'm going to multiply everything that I see, this whole equation, I'm multiplying by a 4. And you get 12x plus 24 equals -3x plus 3. So what did multiplying everything by a 4 do? It got rid of those 4's that are in the denominator. Okay? How did I go from how to find -3x? Because 4 times -3/4 is a -3. Now we have to solve for x. So here's my suggestion to solve for x. You're going to add 3x both sides. And you get 15x. You're going to subtract 24 from both sides. And you get -21. So we have 15x equals -21, and we have to divide both sides by 15. And what is x equal to? What is -21/15? If we divide both sides by 3, what would that give us? All right, -7/15. decimal is negative? I know Austin knows what decimal is. What's negative 7 over 5 decimal? Negative 1.4. So listen, Austin probably on his paper has negative 1.4. On my paper, I have negative 7 over 5. But I understand I dispute both fraction and decimal, so it'll be okay. So right here, what we're going to do is we're going to type in, right here, I have a negative 7/5, or if you put negative 1.4, that's okay. Oops, sorry. Go back. All right. Now, how do we find our y value? All you have to do, if you wanted to, I'm going to take this equation right here. I'm going to write y equals 3x plus 6. And what am I putting in the place of the x? I'm plugging in a negative 1.4, and I'm adding 6. All right? So, if you plug that into the calculator and press enter, I'll give you your y value. All right? So I think that's negative 4.2 plus 6. And what is 6 minus 4.2? What do y'all get? 1.8, which is 1 and an eighth. No, 1 and 8/10, which is 1 and 4/5. All right, which gives me 9/5. Okay, so right here, I'm going to write 9/5. So I'm going to write 1.8. So these right here are my two vertices. You're like, that is a lot of math by hand. Can we use the graphing calculator? And sure, you can use the graphing calculator, but what two lines do we have to plug in? We got to plug in the blue and the red. So go to your graphing calculator, show you how easy it is. Hit y equals, type in 3x plus 6. Go down here, I'm going to change this to red so you guys see I'm talking about the red line and not the green line. There we go. Changing it to red. Press OK. It's almost time, so hold on. It's almost time. Let me finish this up. Type in negative 3 divided by 4x plus 3 divided by 4. Graph it. Where the two lines meet. Hold on. Second, trace. Number 5, press enter, enter, and enter. And you guys see your point of intersection right here at negative 1.4 and 1.8. Now you have to take that information and plug it into your function. We'll finish this on Tuesday.